Students, in last class we have studied regarding dissociation of weak acids and weak bases and relative strength of acids and ionic product of water and pH of some solutions also we have discussed in the last class. So in today's class we will discuss regarding buffer solution and salt hydrolysis. So in today's class we are discussing regarding buffer solution, in that acidic buffer and basic buffer, and what is buffer index we will discuss in today's class, and salt hydrolysis, salt of strong acid and strong base, hydrolysis of salt of strong acid and strong base, and then hydrolysis of salt of weak acid and strong bases we will discuss in today's class. So now, what is buffer solution? A buffer solution is one which can resist change in its pH value on the addition of an acid or base. Generally, if you are taking any common solution, to that if you are adding a acid or a base, that causes the change in the pH. But what is the difference between the buffer solution and the common solution means? If you are taking a buffer solution and to that if you are adding a acid or a base, what happens? There will be no change in the pH of the solution. Why means? Because buffer solution is one which can resist the changes in its pH value on the addition of an acid or a base. Such a type of solutions are called the buffer solutions. Example for the buffer solution is ammonium acetate solution. And now, what is buffer capacity? The capacity of a solution to resist alteration in its pH value. To resist the alteration in its pH value is known as its buffer capacity. What is the buffer capacity? The capacity of a particular solution, whichever the solution we are considering as a buffer solution, the capacity of that solution to resist the alteration in its pH value is known as its buffer capacity. Now there are two types of buffer, acidic buffer and basic buffers. First we will discuss acidic buffers. An acidic buffer is a combination of weak acid and its salt with a strong base. What is an acidic buffer? Acidic buffer is a combination of weak acid and its salt with a strong base. Example, they have given acetic acid and sodium acetate, and other examples are also there. What are the acidic buffer? Acidic buffers are the buffers where there is a combination of weak acid and its salt with a strong base. That is weak acid and salt with strong base, generally called conjugate bases. And what are basic buffers? Basic buffers are the buffers which are composed of a mixture of weak base and its salt. Weak base and its salt, they are considered as the basic buffers. And they have given here the dissociation constant for the base can be written as BOH. It is a weak base, consider it as BOH dissociates to give B plus plus OH minus, and the dissociation constant Kb. Kb is called the dissociation constant, is equal to concentration of B plus into concentration of OH minus divided by concentration of BOH. Or you may write concentration of OH minus is equal to Kb into concentration of BOH divided by concentration of B plus consider it as equation 1. It is a dissociation constant for the basic buffers. What is a salt hydrolysis? The phenomenon of the interaction of anions and cations of the salt with the H plus and OH minus ions furnished by water yielding acidic or alkaline or sometimes even neutral solutions is known as salt hydrolysis. What is a salt hydrolysis? The phenomenon of the interaction of anions and cations of the salt with the H plus and OH minus ions furnished by water yielding acidic or alkaline or sometimes even neutral solutions is known as salt hydrolysis. Generally, a salt contains a cation and an anion. When we are dissolved in the water, what happens? The H plus ions and OH minus ion present in the water, they react with the cation and anions of the salt. So what happens? They are yielding acidic, alkaline or sometimes even a neutral solution. That process is called the salt hydrolysis. Now the salt hydrolysis of strong acid and strong bases. The salts of strong acid and strong bases do not hydrolyze. What is the reason behind this means? Consider an example, KCl, potassium chloride. When it is dissolved in water, its ions, what are the ions present in the KCl? A cation K plus and an anion Cl minus. They have no tendency to react with H plus and OH minus ions of water. This is because the possible products of such interactions, namely KOH and HCl. If the K plus ion reacts with the OH minus ions of the water, what will be the product? The KOH. If the Cl minus ion reacts with the H plus ion of the water, what will be the product? HCl. The product is HCl. These possible products of the strong acid and strong bases, there is no almost completely dissociated. They are themselves almost completely dissociated. Consequently, there is no change in the concentration of H plus and OH minus ions, and the solution continues to remain neutral. The solution continues to remain neutral. Thus, salts of strong acids and strong bases do not undergo hydrolysis, because one of the example we have taken, that is KCl. If the K plus ion reacts with the OH minus ion of the water, the product will be KOH, and the Cl minus ion react with H plus, the product will be HCl. These KOH and HCl are themselves almost completely dissociated. So there is no change in the concentration of H plus and OH minus ions, and the solution continues to remain neutral. The solution continues to remain neutral. Thus, salt of strong acid and strong bases do not undergo hydrolysis. So some of the examples are also given here. Salts that produce neutral solutions, salts of strong acids and strong bases. Example, solution of MgBr2, salt of strong acid plus strong base, 2HBr plus of MgOH twice gives rise to 2H2O plus of MgBr2. There is a formation reaction, and then what happens? MgBr if undergo dissociation, what it will be? Mg2 plus of 2Br minus dissociation reaction. But there is no reaction between Mg plus 2 ion and water molecule, and also Br minus and H2O water molecule. There is no reaction because weak conjugate acid and base do not hydrolyze, means do not react with the water. So next is hydrolysis of salt of weak acid and strong base. To explain this, take an example of sodium acetate. Consider an example, sodium acetate. When dissolved in water, it undergoes almost complete dissociation into Na plus ion and acetate ions. The acetate ions will take up some of the H plus ions furnished by the slightly dissociated water molecule to form the feebly dissociated acetic acid. Feebly means less dissociated acetic acid. Then in next step, what happens? The undissociated water must further dissociate so as to maintain the constant value of Kw. What is the Kw? The dissociation constant of water. So the Kw is equal to concentration of H plus into the concentration of OH minus. And then the H plus ions are again taken up by acetate ions. So this leads to an increase in the concentration of hydroxyl ion and decrease in the concentration of hydrogen ion. What happens? There will be an increase in the concentration of hydroxyl ion and decrease in the concentration of hydrogen ion, and the solution therefore becomes alkaline because hydroxyl ions concentration is increasing and there will be a decrease in concentration of hydrogen ion. So therefore the solution becomes alkaline. Thus the aqueous solution of the salt of weak acid and strong base is alkaline because of hydrolysis. This is the salt hydrolysis of weak acid and weak base. So in this way, in today's class, we have discussed regarding the buffer solutions. What are the buffer solutions? What is buffer capacity? And then types of buffer solutions we have discussed. And then salt hydrolysis. What is salt hydrolysis? And salt hydrolysis of strong acid, strong base, they do not undergo hydrolysis. This concept we have discussed. And then salt hydrolysis of weak acid and strong base we have discussed in the today's class. Thank you, students.